when data have equally spaced inputs, which is our x values, when it's equally spaced, type of function be used to model this data. Linear data has something called first differences, and quadratic has second differences. And I'll show you what that means. I'm going to use color because I like color. So if you're that same person that likes color, I'm using color to do this. So what we're going to do to determine what kind of model this should be is we're going to look at the outputs, the y values, and we're going to find what's called finite differences. And the finite differences would be, how do I get from 9 to 4? How do I get from 9 to 4? 5. That is a difference of 5. How do I get from 4 to 1? 3. How do I get from 1 to 0? How do I get from 0 to 1? Add 1. How do I get from 1 to 4? Plus 3. How do I get from 4 to 9? That's 5. So what we see here is a pattern, but these finite differences are not the same number every single time. It is not a constant pattern. So what I'm going to do is called second finite differences. What I'm going to do next is second finite differences. These would be first finite differences, but they're not a pattern. So I'm going to take another step and I'm going to do second finite differences. So I'm going to take my -5 and I'm going to take my -3 and I'm going to say, what do I do to -5 to change it into -3? Is it getting bigger or is it getting smaller? -5 to -3 is we're getting bigger. We're adding 2. How about from -3 to -1? Add 2. How about from -1 to +1? Add 2. How about from 1 to 3? And from 3 to 5. So now we have constant finite difference. Constant meaning it's the same number every single time. Like the green ones, there was a pattern there, but the orange ones, they are the same. So this is called constant finite difference. Because they're all the same. The number of differences that you go through before it's constant, the number of differences that you go through before it's all the same number is going to tell us the power of the x. It's going to tell us the exponent on the x. So the number of finite differences, I'm going to write this down. The number of finite differences to get constant tells us the exponent on the x in the equation. So if I go through 2 finite differences in the second finite difference where it's constant, that tells me that this equation is going to have x to what power? It's going to tell us x to the second power. Now they've already told me this is the ordered pairs for f of x equals x squared. They told me that. I should have already knew that 'cause they told it to me, but you'll see the next 3 examples, you don't know what those are. So we're going to use patterns and finite differences to figure out what the parent function would be for each of these. Okay? So So let's look at our first example down here. Now, I made these up and I took a screenshot from my graphing calculator. So that's from the table in the graphing calculator. Let's see. We're going to input our x's. Those are all equally spaced. So we're going to look at our y values, and we're going to go from -8 to -5. How do we get from -8 to -5? I'm going to add 3. We're getting bigger. -5 to -2. Plus 3. -2 to 1. Plus 3. 1 to 4. 4 to 7. 7 to 10. 10 to 13. Do we have constant differences? Okay. So the first finite difference is constant. I'm going to write that. First finite difference is constant. So this data is, so if we have the first finite difference is constant, that means I'm going to be x to the what? To the first. What kind of graph is x to the first? Linear. It's a line. So this data is linear. So if I were using my regression feature calculator, I would use linear regression. So I want you to start finding the differences for the second one. If you need your calculator because they're big numbers and please make it go faster. So what I noticed first about the data is it's going down. So I went first and I just put negative signs. From 135 to 94 to 61 to 36, it's going down every single time. So I put negative signs. Are you typing it in your calculator and getting positives and writing down positives? Anybody? 135 minus 94 is not correct? Oh yeah, because I typed in 74 on my calculator. You're right. Or 41, the other way. Yeah. Sorry, I just typed it in my calculator wrong. Thank you. So what's happening is we're going down every single time. So I put a bunch of negatives in there. If you type in your calculator, so you can see I typed it wrong. If you type in your calculator 135 minus 94, that's going to give me a positive 41. So to type it in your calculator correctly, so it gives you the right sign, you always take the second value. I'm going to write this down. You take the second value and subtract the first value. That's how you can get these numbers. If you're using your calculator, you're going to take the second value, 94, and subtract the first value, 135, and that's where it's going to give you the correct sign. But I'm combining using my calculator and at the same time just noticing they're going down, so it's subtraction. Now, are these constant? No. So we're going to do it again. So now, if I'm going to subtract the second value minus the first value, I'll have to type in negative 33 minus negative 41, which is 8. But as a shortcut, I might just say, what is 41 minus 33, and just know that it is going up, to know that it's positive. What's the difference between 33 and 25? 8. The difference between 25 and 17 is 8. 8, and then 8. So second finite difference is constant. Theta is quadratic. It'll be like x squared. This is called quadratic. So if we were using our regression feature in the calculator, we would use quadratic regression. Yes, Dakota? No, you have to do negative 25 minus negative. You always do the second one minus the first one. Negative 30, whoopsie. Minus 20, negative 25 minus negative 33 is positive. Yep. All right, work on that last one. Before I even start, I'm looking to see that this goes positive. This one's going positive. This one's getting positive. This one's getting positive. Looks like they're all getting positive. Oops, not positive. So is this linear?
No.
No, well. You have to do the second value minus the first value. So the second one, negative 40, minus negative 150. Okay, now I'm going to do my second differences. I notice this is going down, this is going down. From 4 to 4 is 0. Then it's going up and up and up and up and up. Which one? The last number? Yeah, I typed it in wrong. I'll fix that in a second. Thank you. Okay. Is it quadratic? What do I do? Oh yeah, do it again. Keep going. I need another color. Yeah. There's a difference between and you doing it yourself. I mean, I'm doing it fast and I'm putting the answers up there because we have a time constraint, but you should be able to get some of these before I finish all of them, unless you're talking. So I went and I found my differences. All of them are getting bigger and bigger and bigger, so I put pluses for all of them, and they're all 24. So what does that tell me about this stuff? Third finite difference is constant. So the data is, does anybody know that answer? What did you think, Sophia? I couldn't read your lips. So quadratic would be to the second power. Quadratic. What power will this data be? Third. What is that called? Okay, so the graph itself is called cubic. And we will cover cubics in chapter 4. To the fourth power would be called quartic, because quadratic is to the second power, right? Why what? Well, because the x values are all spaced evenly, they all go up by 1. So if the x to determine what kind of data it is. Now on this, are the x values spaced evenly? So for this next question, the x values are not spaced evenly. I'm not going to do the differences to figure this out. I'm going to do it a different way. So this table shows the efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. So what we need to do is figure out what regression feature I should use. So what I want you to do is, with your graphing calculator, we're going to enter this data in L1 and L2. What button do I start at? Stat. Got it. Edit. Go up and clear the stuff we did last time. When you're done, you should have the same amount of values in the x column and the y column, just in case you missed one. I'm not going to slow down because you're not paying attention. You can go back and watch this video later. If you're still not bringing your graphing calculator to class, you're putting yourself at a huge disadvantage. You see how much we're using it? Can you do this stuff without the graphing calculator? Cannot. So now, in order to determine which regression, we need to go look at the picture. So we're going to graph these. We're going to plot these. If I hit graph right now, I'm going to have a problem. Does anybody know what my problem is? Oh gosh, I have something in there too. Also, What do I need to do? Well, my stat plot is on, so that's not my problem, because I had it on last class. What is my problem, though? My window is messed up. It's not messed up. It's like that nice 10 by 10 by 10 by 10. But when you look at the numbers, they don't fit in there. So I'm going to go to my window, and I'm going to change my x's. It looks like I don't need any negatives because x's is miles per hour, and we can't go back in time, or we can't go backwards. So I'll just make my x's go from 0 to what is the biggest x. So maybe I'll go to 100. That sounds like a nice answer. And I'll count. That's what I'm enough. My y values, there's no zeros there, so no negatives, so I'll start at 0. And it looks like the highest my y's go is in the 20s, so I'll just go to 30. And we'll make the scale 3. So when I hit graph now, my points plotted. What does that look like? That looks like a parabola that's reflected, right? So that means I'm going to use quadratic regression. So it looks like quadratic. Use quad reg for equation. So how do we do that? Stat, and then calculate, and then number 5 is quad reg. So it gives me my A, B, and C value. We'll just use 2 decimals because there's a lot of them. We'll use 2 decimals. I'm going to approximate it here. Y equals negative 0.01x squared plus 1.37x minus 7.14. I put it in the ax squared plus bx plus c form. What are you asking? From the C value, 7.14. Yeah. Right. I'm going to copy it so I don't have to put the whole thing. I'm going to make my calculator do all the work. Okay, so yes, we're going to use the whole thing. So now, in order to copy it into here, we're going to go to the y equals. So we're sitting in y equals. How do we copy it? Bars, thank you. Bars, and then statistics number 5, and then EQ, regular EQ, and it's clear for us. Bars, number 5, EQ, enter. From here, when I hit graph, it should look pretty close to that data. Now they have a question for us. It says use the model to approximate the optimal driving speed. The optimal driving speed. What does that mean? What are we trying to get? What's the optimal driving speed? You guys are around driving ages. What? Average is not optimal. What's optimal mean? What does optimal mean? What does optimal mean? Bryce, do you know what optimal means? No. Yeah, Max? It's like the best. The best, is that what you're going to say? Yes, like Optimus Prime. It's the best driving speed. When you use a car and you have to pay for gas, When you have to pay for gas, what kind of driving speed do you want to have? You want to, when you compare it to gas, what do you want your miles per gallon to be? What do you mean by optimal, though? Really high. We want it to be the highest amount. So when we talk about the best driving speed, we want to look where our Y's are the highest. That means we have less gas to pay for out of our own pocket because we're driving at a way that uses the least amount of gas. Or you get the most miles per gallon, I should say. So let's look at our calculator. If we're thinking about the highest Y possible, and we're looking at this picture, where is the highest Y possible? It is the vertex. And we call that the maximum value because it's the highest value. So we're looking at the vertex, and we want the max value, the highest value. So I'm just going to sketch this graph. We have a graph like this. We're trying to find that max Y value. Yes? No. Do you know it? How do you look it up?
Second.
Okay. Okay. That's what I'm going to show how to do. All right. There is a way to find the vertex on the calculator. Okay. I'm coming. There's a way to find the vertex on the calculator. You're going to do second trace, which is calculate. And then we're going to use the vocabulary that I was just saying to figure out what we're going to. I fixed it. I'm now fixing the window. The window was really big.
I couldn't just not use it on. I got tried to grab it.
Bars. 5. Sorry, I'm troubleshooting right now. Whoa, thank you. All right. So again, please try to help around you. Couldn't help each other because both of their somebody who zoned out for a moment and they're like, how do you do this? If you could just quickly tell them, that would save us some time. If you have no idea how to fix it, I can fix it. What's wrong, Katie? It doesn't look right? Okay. Do you guys know what we're going to press? We're trying to find the maximum value. You're going to press 4. And then I have to explain what's happening next. Oh, you think your data's wrong? Did you not have the same equation? This part you're going to need to listen to. Unless you've used this before. Number 4 is what I'm going to choose because I want the maximum. Hold on. I just chose the wrong one. 4. It says left bound. That means left boundary. So what you're going to do, since this is approximately where the vertex is, I'm going to pick a number that on the x-axis that is definite to the left of where I think the vertex is going to be. Somebody yell out x. It doesn't matter. 5 works, 0 works, anything to the left of where I think this middle is going to be. I'm just going to do type. Do you see there's a line there?
Yes.
This is telling the calculator, I want you to look in between this line, and then we're going to tell it where else to look. You have to tell the calculator where you're trying to find a maximum value. So now it says right boundary, right bound. What is a number that's definitely on this side of this vertex? I don't know that 50 is definitely there. Well, I'm counting by tens, and this goes up to 100. Yeah. How about 80, 90? Like, we'll go with 80. Why not? Something that's definitely there. So now I have a window, and you're telling the calculator, let's look somewhere in between 10 to 80 to find the highest point. That's what you're telling your calculator. Your calculator cannot read your mind. It does, though, say, can you give me an approximation so I don't have to work that hard? So somewhere in the middle would be what number? 50. I'm going to type in 50 to help it out. After that, you hit enter, and it tells you the maximum. It tells you the vertex. Only one from the vertex. But what do I want from the vertex? Which is the y, yeah. So our, no, we don't want the y. I lied. I'm sorry. The y value is the max value, but we're trying to find the driving speed. We're going to use our x. The max value is the y for optimal speed. Like it's asking what our best speed is. So what is the speed that we should drive at? 48.46 miles per hour. So I have a number to give because I was reading and thinking about what is driving speed. That's my x value. Okay, let's do another one. NASA can create a weightless environment by playing a plane in a parabolic path. I don't even know what that means. The table shows 8 feet of a plane t seconds after starting the flight path. After about 20.8 seconds, the passenger begins to experience a weightless environment. Find the function to approximate the height at which this occurs. So we need to know what kind of data this is. So let's type in the data, stat, edit, clear your previous data.
Oh yeah, when you put in the equation, it was wrong. You gave me the wrong equation. And you're like, let's do this.
Then you have the wrong data entered in. I went off whatever your data was. I didn't type in the equation. I just copied it. You could still go through all the work with me that we did. Is you would have a different answer because you might have like typed something in wrong. You know what I'm saying, Devin? You know what I'm saying? Like you might have typed something in wrong here. Okay. Bryce, do you want to come over and do this one in front of the class?
No.
Then quit talking.
Yeah.
So if you do type something in wrong, if you do type something in wrong, then you're going to have the wrong answer. So just be careful. So after we type the data in, we want to see it to see what kind of regression to use. So the window that I used last time, will that work for this data? So let's go back to window and let's change our window. Looks like X can go from 0 to maybe 50, and I'll count by 5s. But my Y's, 2600, we can start at 2600. And go to what? 35, or not 2600, 26,000. Go to 35,000. I'll count by thousands maybe. I don't know. What shape does this kind of look like? Line, quadratic, something we don't know? Okay. Well, it looks quadratic to me. It looks like a parabola. So then if it looks like that, we're going to use quadratic regression. Stat, calc, 5. Ooh, that turned out like perfect. Nice. Probably not really. Let's copy that equation into our y equals. Let's go to our y equals. And we're going to copy it in there. So vars 5 EQ regular EQ graph. And I'll wait for you guys to catch up.
Started to not work? It doesn't not work because it turns off. But it doesn't.
Yeah, it turned off. And then when I turned it back on, it turned off again.
Then it, yes, then it is the battery. So here, you're sitting close to plug it in. And then you just whoever's clear. Now do bars. I hit graph. What happened? Did you already do quadratic regression? Did you already do number 5 here? Did you do that yet? Oh, we have to do that first. Now go do y equals bars. Should we change our variable for out the list? Thank you.
Would X be
Uh-huh. I All right, Katie reminded me of something important that's, well, it's kind of important, but if you guys ever do a big ideas online assignment and you don't notice it, they do this stuff to you all the time and you'll keep hitting check and you'll be like, I don't know why I'm doing it wrong. They did not use X and Y. They used T and H. Change my equation. T would be like the X, so this will be H equals negative 11 T squared plus 700 T plus 21,000. We're almost out of time. This asks to find the function to approximate the height at which this occurs for, it says 20.8 seconds. That's where you can do second trace value and type in 20.8. Your assignment is this packet starting at number 6. Your assignment is this packet. Well, they're like screenshots from the book, so it's not like through. It's just like do the rest of the packet. Yes, the rest of the packet.